Think about the universal remote on your coffee table. Point it at your television and press this main power button, the television turns on. But if you turn your wrist, point that exact same remote at your air conditioner and press the identical button, the AC kicks on. Point it at a projector and the projector lights up. You are using one single button, but that button causes completely different behaviors depending entirely on the object receiving the signal. In the world of programming, we have a specific word for this way of working. It comes from Greek, polymorphism. If we break that down, poly means many, and morph means forms, many forms. In coding, polymorphism means you can give one simple universal command and get different specific results based on the object you are talking to. To see how this actually works, we need to step inside a computer's brain and look at how different languages handle multiple commands. Some strict programming languages use a feature called function overloading. This means you can create two commands with the exact same name. You might have one rule to add two numbers and another to add three. But Python reads instructions top to bottom. If you write two rules with the same name, Python simply overwrites the old rule. If you try to use that first rule to add two numbers, it will fail. The computer has completely forgotten the first rule ever existed, because only the very last instruction survives. Because Python only keeps the most recent version of a command, it encourages you to write one flexible rule that can handle different situations, like a single add command that's smart enough to count how many numbers you've given it. Python's preferred way to handle these adaptable commands is through method overriding. Picture a digital pet store filled with animals waiting for instructions. This relies on runtime polymorphism. That means the computer waits until the program is actually running to decide which code to use. It's like a game of Simon Says between a parent animal and a child animal. The parent class acts as a template, giving a generic rule, like a sign reading inside parent. But the child class creates its own specific rule. When commanded, the child's rule completely ignores and totally replaces the parent's generic rule. This decision happens at runtime. Python looks at the specific animal standing in front of it right in that exact moment, and only then does it pick the rule that fits. The specific object is smart enough to override the general rule whenever you call the command. Let's step out of the pet store and head over to a digital pond. Here we find a specialized approach called duck typing. If you are walking in the park and you hear a quack coming from the bushes, do you need to stop and check the animal's DNA to prove it's a duck? Python's answer is a firm no. Python operates by a simple philosophy. If it walks like a duck and quacks like a duck, treat it like a duck. Because of this, you can have a dog and duck class that are completely unrelated, no shared family tree at all. But when you trigger the sound command, the duck quacks and the dog barks perfectly. Python doesn't care they are entirely different species. This works because Python is dynamically typed. This means it doesn't care about the label or category you gave an object earlier. It only cares if the object can perform the action you're asking for right now. Which brings us right back to the universal remote sitting on your coffee table. Whether you are pointing it at a television, an air conditioner, a digital dog, or a rubber duck, your job is exactly the same. You just press the button. Polymorphism keeps your commands incredibly simple. You issue the instruction and you let the objects themselves do all the hard, specific work.